Now we start the new things, that is the differentiation of determinants. Okay, you will be surprised to know that differentiation of determinants, how this is possible. Yes, this is possible. And let's take, I am taking some determinants. So determinants is given delta x, okay, function of x, okay. So that is given, that is fx, gx, and ux, and this is going to be the vx, okay. Now we have to find out the differentiation of delta x, okay. So this is just to keep this in as a concept, okay. Please keep it just as a concept. So d by dx of delta x, and that is going to be what? So first differentiate the first row, differentiate the first row, okay, differentiate first row, and second row is going to be as it is, plus now differentiate the second row with respect to x, okay, and first row is going to be as it is, fx and gx, okay. So now write it. So in this way, by using this, we have to solve the problems. Suppose that if this was the, this is the 2 cross 2 okay, matrix, so we are finding the determinants of this, okay. If this was 3 cross 3, so in that case we had to do the same thing, first row, second row, and then third row, okay. First differentiate the first row, plus differentiate second row, and then differentiate the third row, and remaining are going to be as it is, okay. So in this way you can solve it, okay. Now uh, take let's take some problems, okay, and problem will help you to get the answer. So let's try the question, and the question is number first, and the question is fx, that is defined, fx is equal to x plus a square ab plus ac, and ab x plus b square bc ac bc, and x plus c square. Let's, you have to find the f dash x, you have to find the f dash x, okay. So please try it. So let's, I'm giving some hint to you, okay, how to solve it. So we have to find the f dash x, and f dash x is going to be, f dash x is equal to differentiation of first one, that is going to be 1, and these two are the constant, okay, and write these two as it is, x plus c square, okay. And for the second, first row is going to be as it is, and second row it is going to be constant, so 0, 1, and 0, ac bc, and x plus c square, plus, and first row is as it is, second row is as it is, okay, and differentiate the third row, so 0, 0, and 1. So what you have to do, just open this determinants with respect to the first row, open this determinants with respect to the second row, and with respect to third row. Why? Because we generally open our determinants with respect to the row or column which contain maximum number of 0. So if you solve it, okay, I think there is no need of my solution. If I solve, I will do the same thing as you do. Let's solve it, and you will get the answer 3x square plus 2x a square plus b square and plus c square, okay. So this is the simple solutions, and you can do it. There is not any difficult solution behind it, otherwise I could solve. So it's easy, you can do it, okay. Now we can also so this is the question, okay, not so much difficult, very easy question, Okay, so but still we want to take some other question, one more question, and that is going to be what? Let's take the one more question, I'm telling you. And question is fx equal to x to the power n n factorial 2 and cos x cos n pi by 2 4 sin x sin n pi by 2 8. Okay, so we have to find, we have to differentiate it. So if we differentiate, we have differentiated n times x. Okay, and f x then equal to 0. So we have to find the answer of this. We have to differentiate this n times and then put x equal to 0. Okay. So what you can do in this question, process is the same. Okay. As I have told you that differentiate the first row and then for the second row and then write the third determinants and differentiate the third row. So let's find the first determinants of this, and that is going to what? So that is going to be f dash x is equal to n x power n minus 1. This is 0 because constant. This is also 0 because this is also constant. And cos x cos n pi by 2 sin x sin n pi by, and it is x power n, and differentiate the second row, and that is going to be minus sin x and cos n pi by 2. This is the constant. Okay, it's going to be always constant, so 0. And this is constant, so it's also 0. Okay, I did this 0. And sin x sin n pi by 2 8. Okay, plus first and second column, a row, you can write the it is x power n factorial 2 divided by, not divided by, cos x cos n pi by 2 and 4. It is going to be cos x 0 and 0. Okay, so if you solve it, what you will get? You will get f dash x tend to 0. Okay, so we have to differentiate it n times basically. So if we differentiate it n times, what we will get? It is cos and sine. Okay, so I think now it is going to be difficult. Okay, you just put now only this. When I will teach you the higher order differentiation, then it is going to be easy. Okay, so only have this in your mind. Okay, because it's power n, so differentiate n times, it's going to be difficult. Only have this in your mind. Okay, that's make you work very easy. So let's, x is equal to 0, so it is going to be 0 0 0, and whatever is coming here, that does not matter. Why? Because if all the elements of any row or column is 0, it means value of the whole determinants is 0. Plus put here 0 also. Okay, so 0 0 and 0, because sin 0 0, here there are going to be some constant. If all the elements of one row or any row or any column is 0, it means determinants of that is going to be 0. Similarly, it's going to be 0 n factorial 2 and cos 0 is 1 and cos n pi by 2 4 and cos 0 is 1 0 and 0. Obviously this is going to be 0. Okay, so you can write it like this also. as you know that this contain maximum number of 0, so open with respect to this row, and this is going to be 4 n factorial minus 2 cos n pi by 2. Now it depends that which type of n you are taking. If you are taking n is equal to even number, then it is going to be what? It is going to be like 2, 4, like this. Okay, so it is going to be 1 or minus 1. Otherwise, if you are taking odd number, it's going to be 0. Okay, so it depends on your choice. Okay, you can make two cases when n is even and odd, and you can get the answer. Okay, so now you can do it. It's not difficult task. Now what we will do, we will talk about the higher order derivative, and in next video I will just give you some problems based on the derivative of the my determinants and higher order derivative. Okay, so now let's discuss the concept of higher order derivatives. So next thing is the higher order derivative. Okay, so let's write it and we will solve the question. It's very clear. Suppose that I am having y is equal to yx, okay, or fx, gx, whatever you want. And if I differentiate it one times, I will get dy by dx. So this is called the generally first order derivative. What is this? This is the first order derivative. Similarly, if I differentiate it again, and this is the second, so this is called the second order derivative. If I differentiate it again, this is going to be third order derivative. Okay, in the similar way I can differentiate it multiple times, and if I differentiate it n times, this is going to be nth derivative. Okay, so nth order derivative. Okay, so nth order derivative. So it's this is this simple things: differentiate and get the answer. Sometimes there are some difference of notation also. We in different books, for the first order, dy by dx is one notation, and other notation is sometimes we use y dash and sometimes y1. Sometimes we use y double dash and sometimes y2. Similarly, sometimes y triple dash and sometimes y3. Similarly, y power n and y power n, yeah, here. Okay, so now you feel that why this power n? N means n dash. Okay, here in this case this is n dash. Okay, so these were the notations that we have discussed. Okay, now let's take one problem and we solve that problem. Problem is problem number first, and that is what? Y is equal to e to the power tan inverse x. Okay, and we have to prove that 1 plus x square, double derivative of this, equal to 1 minus 2x dy by dx. Okay, you can say we have to prove that, we have to prove it. Okay, so write this question and then we will prove it. Okay, we have so many questions, and all those questions we can discuss in next episode. And problems based on the first definition of derivative we will also discuss in the next lecture. Okay, and that lecture is going to be very important with the context of JE. Okay, so because they are asking many questions from this type of topics, so let's start solving it. So first we have to differentiate it. Okay, now differentiate one times dy by dx is equal to e to the power x is e to the power x, and differentiation of tan inverse x is 1 by 1 plus x square. Very simple. Okay, now what you can do now, don't differentiate now, just cross multiply, and you will get 1 plus x square dy by dx equal to e to the power tan inverse x. So this is what you have. Please keep in mind that if you are not differentiating it, if you have differentiated it, आपने इसको differentiate कर दिया और आप इसको एफ एक्स बाई जी एक्स को सॉल्व करेंगे लेंदी हो जाएगा. आपको यहाँ पर थोड़ा सा चालाकी करनी है। जब भी क्वेश्चन सॉल्व करने हैं, आपको देखना है कि प्रूफ क्या करना है, आंसर क्या लाना है, ऑप्शंस क्या है, उसके अकॉर्डिंग आपको चलना है और वही आप प्रूव करने की कोशिश करनी है। आपने इसको क्रॉस मल्टीप्लाई किया, अब हम इसको फिर से डिफरेंशिएट करेंगे और हमारा आंसर आ जाएगा। तो फर्स्ट और सेकेंड फंक्शन के हिसाब से इसको हम डिफरेंशिएट करते हैं। इसको डिफरेंशिएट करेंगे, हमारा आएगा 2x dy बाई डी एक्स प्लस 1 प्लस एक्स स्क्वायर, differentiation of this is going to be d double derivative of, okay, with respect to x, and differentiate it, e to the power tan inverse x divided by 1 plus x square. So ये आपको दिख गया, और dy by dx 1 y 1 minus 2x dy by dx. Okay, that's fine. Yeah, don't worry, don't worry. That's fine, because what is this? This is the dy by dx, and what is this? Same thing, equal to dy by dx. Now you can bring this term this side and take dy by dx, and that will become 1 minus 2x. Okay, so that is the simple proof of this. So now my suggestion is that please all of you solve this question, and if you have any doubt you can ask me. Okay, and in next lecture we are going to discuss a very important things. Okay, so let's wait for the next lecture, next episode, and we will continue in discussing. And if you have any problem from your side, you can also tell me, or if you think that you have any doubt, any confusion in any particular topic, you can tell me. I will continue in that. Okay, so this is for today class, and next class I will tell you some other things. Okay, thank you.